Mr. Takemoto, Minister of State for Science and Technology Policy, Dr. Hamaguchi, President of Japan Science and Technology Agency, Dr. Kobayashi Yoshimitsu, Executive Member of the Council for Science, Technology and Innovation and Chair of the Visionary Council of this Moonshot R&D program. Ladies and gentlemen, friends and colleagues, good morning. I'm honored to be here as part of this symposium. The way I make presentation today is far from Moonshot, without using slides and very much earthbound. But anyway, my job is to discuss the new funding program initiative called the Moonshot Research and Development Program. For the past at least 4 or 5 years, I have been calling on the government to establish the position of chief technology officers in each ministry, and these officers, in consultation with the Council for Science, Technology and Innovation, would be responsible for upgrading the state apparatus itself. This has not come to pass, unfortunately. But in tandem with the proposed program upgrading of the Japanese state as a governing machine, I also called for the establishment of a new mission-oriented funding program that should succeed the current impact program, and that would be geared mainly to research and development of the basic sciences and emerging technologies. And I'm pleased to say that this new funding scheme is there, geared at least in part to research and development of the basic sciences and emerging technologies, and is now in the process of being designed. Having said that, let me underline 3 points that I believe are important to keep in mind when designing the program. 10 years ago, when I was serving as a member of the Council for Science and Technology Policy and started discussing the 4th Science and Technology Basic Plan, the word emerging technologies was not yet in use. The current 5th Science and Technology Plan, which sets Society 5.0 as its overall goal for the plan, does not dwell at length or in detail on those technologies either, even though the plan mentions some of those technologies. The interesting question is why all of us, not only in Japan, but also in the United States, European countries, China, and other countries, are now investing huge amount of money in emerging technologies and the basic sciences that underpin those technologies. The answer appears pretty straightforward. As AI, robotics, nanotechnology, biotechnology, brain-machine interface, quantum computing and sensing, and other technologies have demonstrated, such path-breaking research and its applications are advancing very fast and promise to have very important bearings on and implications for the future of our society, security, and industry, both nationally and globally. The question is how to design the program to promote research and technologies with such potentiality, with far-reaching impact and implications. The big challenge lies, at least in part, in the very nature of emerging technologies themselves. When we say emerging, we are aware that these technologies are still sort of in the making, or at the embryonic stage of research and development, but they are expected to be with us in the near future. Science and technology are different in purpose. Science is for humanity, but technology has clientship. Any technology is and will be used by someone for some purpose. When we talk about emerging technologies, however, we do not know and cannot know in advance who are or who will be using these technologies for what purposes. That is, we do not know who are their end users and what are their end uses. Scientists and engineers already rely on their own initiatives to identify cutting-edge fields in which to do research and develop innovative technologies. But it is also true that novel creative ideas for promoting and developing science and technology not only define government policy, spur individual entrepreneurship, and affect business strategies. Just as important, creative ideas about end use critically inform the ways in which these technologies will develop. This mission-oriented initiative should be an attempt to address this very important challenge. The second point we need to keep in mind is something all the Japanese participants here already know as quite commonsensical. Japan's policy making and budgeting process, in sharp contrast with, say, the United States, is highly decentralized and dispersed. Directors or division chiefs serve as basic policy-making units, and there are more than 4,000 directors and division chiefs in the government ministries and agencies. Every director, at least anyone who deserves to be in that position of responsibility, thinks that what he or she is doing is important, and they compete for funding to support their policy proposals. But precisely because of this decentralized and dispersed nature of the government policy making and budgeting system, directors and division chiefs tend to come up with these policy ideas without much coordination with other directorates and divisions in the same ministry, let alone with other ministries and agencies. This frequently results in overlaps in their proposed policy measures, as well as gaping holes that no policy measures can address. Attempts have been made to redress this system over the last 15, 20 years. The establishment of many strategic headquarters called Sendyaku Honbu in the Cabinet Office, as well as the political appointment of assistant to the Prime Minister by the Prime Minister's Office, have introduced an element of the top-down approach to the system. And I understand this new Moonshot Research and Development Funding Program itself is a product of the initiative of the Prime Minister's Office. This is welcome, but it does not mean that the Council for Science, Technology, and Innovation can be marginalized. The SHISTI is defined as a high command for government, science, technology, and innovation policy, the cabinet-level organ responsible for mapping out a strategic plan for science, technology, and innovation policy and assessing government's science, technology, innovation-related policy measures. The SHISTI should be in charge of defining the missions of the program, designing the program, overseeing and supervising the implementation of the program, and if possible, using this program as a leverage to spearhead the coming 6th Science, Technology, and Innovation Basic Plan now in the making. And finally, and this is the third point I would like to make, we should admit that all the emerging technologies the new program is funding are dual-use technologies, critical to Japan's national security, safety, and industry. For instance, in the rapidly advancing fields of brain science and neuroscience, it has now become possible, albeit still, I must say, at a very early stage, to use brain waves to control drones. It remains to be seen who will further develop and use this technology and for what purpose. The only thing we can be sure of is that this technology will be used for both industrial and military purposes. For this reason, we should anticipate the problem that in the near future, the very brains and nerves of human beings will likely become a new security domain, equally as important as the existing ones. That means land, sea, air, space, cyberspace, and the electronic spectrum. These are sensitive technologies, that is, critical technologies. We should be involved in the research and development of these technologies, but who should be involved in this area is in itself an important security matter. This is a good opportunity to start thinking about designing a new security clearance system for government-funded research and development program for critical technologies. Only with a reliable security clearance system in place can we safely undertake and promote international collaboration in these fields with our ally and our strategic partners. Now that we have the money and we have the 5-year time frame, it is important to design the program carefully to allow far more flexibility in conducting research and development than currently allowed by the existing program. For now, achieving the expected research outcomes decides whether a program or project is considered a success or failure. This is, I would say, too rigid a definition, because we cannot know in advance what results the research and development of emerging technologies will yield. Research directions may change at midpoint. Outcomes may be secured by other research teams. Failures in scientific research and technological development can be important learning and teaching moments that lead to innovation. A flexible approach takes all of these into consideration rather than foreclose further research in the name of immediate measurable results. I hope that the SHISTI designs the program in such a way that the new program would be a model for future funding schemes. I also hope that the Japanese government will seize this opportunity presented by the increasing importance of emerging technologies to introduce a security clearance system for government-funded critical technology development and promote international cooperation and collaboration in this area. Thank you very much.